Okay, so we're talking about logs. And today we basically just need to review yesterday's, make sure that caught, and then make sure you get good at the basics of graphing. And then tomorrow we'll do more hardcore graphing. And eventually you'll get into, you'll be pretty quickly, we'll be taking a little test on graphing. So, you need paper. Digital paper's fine, but just sitting there is not. Moving on, if I had this, the reason we need exponents is to be able to solve problems like this. Sorry, not exponents. The reason we need logs is to solve problems like this that have exponents. If there's an exponent, then it's handy to go log base 5, and then you go over to the other side of 8 equals x. And the way to say this correct, insert two little words. Base 5 of 8 equals x. All right, I'd like you to write me a log for this one. 427, that is. Funny looking 7. Don't say it. Yes? Yep. You have to leave me something, though. Just so you don't forget to give it back. That'll be fine. Yep. It's not incredibly fast. I got a bigger one. I got a bigger battery, and it's a lot faster. But it slowly charges it up. Okay. You could have said log in the and side. You got to go over here, 427, and then you come here. Goes x. Now. Calculator could calculate that log 427 over log 10, but you're going to be able to, that was a dumb way. Since it's base 10, you could just say what? Log 427. Okay, because if it's base 10, you calculate it can do that directly. The reason that it would be the same is because 10 is actually 1, so when you divide by, anyway, bottom line, that can go in a calculator. But we need to focus on what we're doing right here. Too much talk. Problems like this on the test, more likely, because this can fit in your head, and there's no calculator allowed in the test. So that 9 would really be 3 squared, and instantly you have an answer. What? 2. Because this is 3 squared, and the answer is the exponent on it. All right, so then a little harder than that. Log base 1/16. That's kind of annoying because it seems like, can't I rewrite the 1/16th here as a 16? Nope. You'll never mess with your bases. Leave them alone. But you can take the argument here and rewrite it as 1. How do I change a 16 into a 1/16th? With a -1 power. And now it's exactly the same as the original problem. And now these are the same. And now the answer is -1. So what that means is if you have something like this, 2 log base 1/8 8 equals 4x, this part right here, once you solve it in your head, you're going to replace it with a number. All right, I want you to solve this one right now. Just a simple little log equation. Paper. Latecomer. Don't want you to do it yet. I want you to write it down. AG. Tell me how you start. Log base and it wouldn't be 8 to the power of -1. 1/8 to the power of -1. Okay. Equals 4x. Okay. Hard to rewrite that way. Because by making this and this interchange out, you change the one for the other, you now put a negative. Answer this whole is -1. 2 times -1 makes negative. Divide by 4 on both sides, -2/4. X equals -1/2. Raise your hand if you have that one right. class, at least half the class. All right, we're going to try one more like that. 5 log 4 over the cube root of 16 equals that. All right, the hard in here. And what's your goal there? Trying to write it as 4 to a power. So really, I'm going to go down here and just say over the cube root of 16. I want that to be 4 to the... Well, think of this as having 3 parts to the exponent. The negative part, there's the top of the fraction, and then there's the bottom part of the fraction. What did I say? Bottom, same in plants. On the bottom, and this 3. Only leaves me on the top. This 4, 2. What power do I need the 4 to? There you go, negative 2/3. Now that I got there rewritten as 4 to the negative 2/3, this part right here can be replaced with a 4 to the negative 2/3. So now I've got 4 to the negative 2/3. So then the whole answer to this part right here is negative 2/3. And 5 times that will be negative 10/3. And that's x. So I'm done. Raise your hand if you had that one right. That's more people than last time. Good. All right. Now that's a review of what you were kind of doing last time, except for one thing I'm talking about too much yet is ln. And I gave you some advice about that was really simple and makes these problems way easier. Anytime you see an ln, erase it and put what? Log base e. Because when you got that, you'll see, oh, wait a minute, these two are the same, that's the answer. There was one other pattern that came up a lot. What's that deal with the ln? Oh yeah, replace ln with what? Log base e. And now if this and this are the same, 5 would be the answer. Remember that one? Okay, one other pattern that you need to know. Anytime you have an argument that's 1, doesn't matter what the base is. What's the... This is a 1. What's the... Okay, so one more pattern. What's the answer? 12. All right. Now, let's talk about graphing. This is a graphing test, after all, that's coming up. And so, the main parent graphs, there's 4 of them that you will need. I would write them down for you. Here is the first one, exponentials. We already know this one in theory. This just has a base of about 3, 2.718. See, E is 2.718. So this is just a basically like, almost like saying this. Okay, so anyway, that looks like that. How steep is the line? Nah, that's generally how it looks. If you want exact points, we'll be doing that part later. Okay, next is the graph that kind of goes with that. If I rewrite this as a log, do you get this would be log? Why I switched around? Because what we're graphing now is the inverse of this one. It's a reflection over this. It's generally going to look like that. It's an inverse. So an inverse means x and y will get reversed. As soon as I reverse the x and y, this is an x, this is a y. I'm just trying to get log base e. It's because of x. It's because it's an inverse of this one. Okay, so now what does it look like? And it's a reflection across the line y equals x. It looks basically like that. Okay, y equals log base e of x, just like I said. Now, if you'd rather say ln, I can do that. what happened to the x and the y? Okay, I will remind you. Yes, and I reversed it. And I told you why I reversed it. Because if I leave it the same way, it's going to be this graph. I don't want this graph again. I reversed the x and the y because this is an inverse. This and this are inverses of each other. So that's why I reversed the x and the y. Now, do you have to remember all of that? No, just trying to show you where it came from. All you got to remember is, what does the graph of ln look like? It looks like that. And is it an inverse? Yeah, let's put them on the same graph. If I grab this blue one here, now it's just a rewrite, so I'm going to delete that one. Grab this blue one here and I put it over here. See how that's a flip across this line? They're inverses. That's why the x and y got reversed. Okay, anyway, so there's a parent. There's a parent. This red dotted line I don't really need anymore. Okay, here's another one you need to know. Just, what if it's a plain old number? 2 to the x. Well, that's going to look a lot like the y equals e to the x graph. Still want you to have one down. And which would be steeper? E to the x or 2 to the x? E to the x would be steeper. So this one's just a little less, I don't know, it's judgment call. Steep is steep. Be less steep. If I draw it on the same graph, you'd be able to see it better. But anyway. So then, if we wanted, there's one more that you'd have to know. It would be the ln, not the ln graph, sorry, the y log of x. Wait, I didn't say a base. What base is it then? 10. All right, and if this is a base 10 and this one's a base e, base 10, I think you know 10 is bigger than e. 0.17. So, or 718, sorry. And so 10's bigger, so it's a bigger base, steeper. Kind of steeper. Well, it's very, it's like flatter to the ground. It won't rise as fast. Here, I'll put them on the same graph. Just like the other one was steeper, you know, the bigger the base is this way, or steeper yet, these get as bigger. Like, all right, so 4 parent graph, because if you know these, then from the rest of it, it's really pretty easy. You're just gonna like go plus, move it to the left 1, or -6. Take that graph, move it to the left or to the right 6. Or what if I put a +7 down here? That'd be the whole graph moves up 7. Or if I throw a negative out in front, that's the up-down area out in front or in back. On the outsides here, stuff on the outside, this would mean an up-down flip, this would mean an up-down move. And if there was a negative right there, that would be a left-right or a horizontal flip. Yep. Reflection across the, if it's left-right, it'd be across the y. Yep. This one will be across the x. Okay. So, does the order matter? Yep. Simplest one in the world. Take log of x and then move it where? 2 to the left. And the order really won't matter because there's only one thing. Now, I got 2 things going on. But, are you staying with me? Okay, good. That +2 and that minus there, there's 2 things going on. Isaac, tell me one of the, or which one do you think should be first? Or the +2? Yep. Because normally the multiplies come first, but we're on the inside, so we do it the opposite of normal. So that should be first. So I should say left 2 2 first. And then this is a reflect which way? Left, right, or up, down? Left, right. So that's also known as horizontal. So it's a reflection, horizontal reflection, but we usually say over what axis? The reflection over y. And in that order. Okay. Yeah, if I do just do first names, that's really isn't a big deal, unless it's a special first name that everybody would recognize. But anyways, let's actually start the homework together. I'm going to hand out this worksheet. I'll pause the recording while I'm handing those out. All right, you've got your worksheets now, and let's do the first couple problems together. Number 1, 2, 3, and 4 are just matching, and I hope you have the basics of that down already. Let's talk about number 5. Number 5 says f of x equals ln of... All right, so if I'm supposed to describe how to transform it, well, it's really simple. It's just has one change. It's that. So how do I describe how to transform? I have to even list them in order because there's only one thing. I go left 3, done. Next thing, sketch the graph. All right, I can sketch a graph of this. So graph of this, generally speaking, ln. My teacher told me. Now, one thing though, you do need asymptotes, and I should be more specific now on asymptotes. Only one asymptote for most of these graphs. Like this. Keep rising forever, but it'll never go across the asymptote line this way. Okay? Yes, it's just going that way. Now, it's constantly rising, and another way to say it. All right, so if I were to finish this with a domain and a range, all I got to do is remember domain goes this way. Is there any limits on that? Yes, there is. A 0 is the smallest it'll ever be that way, and then what's the biggest it'll ever be? Infinity, so I put parentheses around those because it'll never touch 0. Oh, wait a minute, it's got to move 3. I haven't shifted it yet. Okay. So I have to move everything 3 to the left. So my sketch, I'm going to cheat and move my axis 3 to the left instead. I know you can. You can redraw it, and how messy you are is not that big of a deal. Okay, so then it's not from 0 to infinity anymore because it's been shifted. Now it's from -3 to infinity. And let's see, the range, is there any limit to this way and this way? No, there's no. It's negative infinity to positive infinity. There we go. And again, these were just little helper things I put in there. You do not need that or that. All right, that's how you do 5. Number 7, I want to give you a hint on. They're going to definitely do this to you. Y equals, and you're going along like normal, and you're thinking it's going to be like this, oh, 5 to the... But what if they put the 5 in the front, and they say minus x? It's actually much more complicated because, do you get how there's a flip involved? Why is there a flip involved? Because this is really negative x plus 5, exactly. You'll be able to do it no problem. Okay, in this case, on number 7, it says 2 minus x, and so that really means negative x plus 2. And then I have to say, oh, that's a flip, and that's a move to the left. And does the order matter? Oh, yes, it does. Do it in the wrong order, you will get the wrong graph. And normally first is the part right here, and so you have to do this part first. So I can start with my log graph, which generally log, which means base 10. So it looks kind of like this. And I'm going to shift that whole puppy to the first left 2. So I'm going to grab this and go left 2. 1, 2, about like that. And then I'm going to take the negative, which is a left-right flip, and this there. It's kind of like that. So my green one will be my final sketch. Didn't I already move it left 2? I think I did. Okay, hold on a second. So that's like 3 questions at once. Move it left 2. I'm going to start over. Here's the back. Now I'm going to shift it left. Now I'm going to flip it across the axis. Something like that. Okay, so the green one, I did shift it left to already. So the green is done. Alright, the asymptote is still down like this. You can just see where the asymptote would be because it's wherever your dotted line or your line is. Alright, very soon lunchtime, not quite yet. Then the last thing it asked me for is the domain and the range. I said it's almost lunchtime. I have done it correctly. I don't want to do it again. I know. I've already redone it to show you people how I did it, but I've done it correctly. I'm going to now finish by just saying the domain and range. The domain is from negative infinity up until I hit 2. And then the range is no limit on range, I mean negative infinity to positive infinity. Okay, we'll do another one after lunchtime. Okay, we're back from lunch, and here is number 8. Number 8 says f of x is equal to -1 plus log x. And what that really means is the same exact thing as if the log x was at a -1 there, and we down 1. So the steps here are describe how to transform it, down 1. Next thing, sketch the graph. Okay, so here's log generally, and then I move it down 1. So it kind of looks a lot the same. I'm just going to take this graph and move it. Alignment being off tries to be crazy. Down. So it's like somebody dragged it down a little bit. And then state the domain and range. Okay, domain, range, and the domain on this guy is there any limits? Yes, there is. So it stops right there at actually. It's been moved over 1, so it's 0. Oh, it's been moved down. That's right. It hasn't been moved to the right. I should leave that asymptote where it was then. So I'm going to undo putting in that asymptote line. Try putting it in the right spot instead. Which is right there. So the asymptote line is still at x to infinity. And the range, negative infinity to positive infinity. No limits on that. Okay. The backside's all review. Again, if you had trouble with yesterday's, you might have trouble with this, but ask me if you need help on that. I'll be glad to help you one-on-one. All right, that's all I got for you on the video.